All right, we're going to work here on 3.18, and I have the drawing all set up here, I believe. It says use the drawing of the 100 Newton uniform beam. So there is one more force we need to put on here. The beam weighs 100 Newtons, and it's a uniform beam, which means it's going to go right in the middle. So this is like a meter stick. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So 10, 20, 30, 40, 50. Here's the middle. And so I actually need to put 100 Newtons in there too, okay, for a down force. Okay, so what I want to do is I want to, it says there's a one force that I want to put on here. I want to determine the magnitude. I want to determine the point of application. Where is it on the beam? And the angle of the single force, which will give static equilibrium. So I want this whole thing to be in static equilibrium. Right now, it is not. And I want to figure out where that force is. So the first thing I need to do is there's two forces here that are angles. So I need to resolve them into, ups and overs. So this one would go up like this and then over to the left. And I could put in that's 30 degrees. And this one here would go up and over to the right. And I could put in 60 degrees there. So I can figure out what those sides are. So 30, sine of 30 times 150, that's half. So that's 75. And this one over here, 200 times the cosine of 60, that would also be half. So this is 100. Let's see, check that. 200 times 60 cosine that's correct, 100. So over here we have 150 times 30 cosine, and we get 130. And then over here we have 200 times 60 sine, and we got 173. Okay, so now I got all kind of lefts and rights and ups and downs. And so I can try to balance some things out. So I'm going to do ups and downs. I have to do those first. And I have a 50 down. I have a 100 down. Ups, I have a 100. And I have an 80. And I have 130. So if I add those up, I have 150 down. And I have, let's see, what would this be? 230, 310. All right, I want to make sure I did that right. 100 plus 80 plus 130, right? 310. Okay, so what does this mean? That means I need some more down. So 310 minus 150 equals, so I need 160 down. Okay, so that's important. I need 160 down. All right, let's look at lefts and rights. I have, so lefts and rights. Left, I have 75 Newtons going to the left, and I have 173 going to the right. Clearly, I need some more going to the left. So 173 minus 75 equals, I need 98 going to the left. So I need to put a 160 down force and a 98 left force somewhere on here. Now, what I want to do now is find the point of application. Where should it actually go? So I'm going to measure from any point I want. I'm going to do from the, actually, if I go, if I actually measure from here, I wouldn't have to, well, let's just go from the end. Let's just go from the end, make it easier just to go from the end. Okay, so I'm going to have clockwise, and counterclockwise torques that I need to calculate out. Okay, so any of the ups, all the ups here are going to be going around this way. That's going to be counterclockwise. So I'm going to take 130 times 1. So 130 times 1. I'm going to have 1, 2, 3, 80 times 3. I'm going to have 1, 2, 3, 4, 5, 6, 7 times 100. And that would be all the ones going that way. Clockwise, I'm going to have 1, 2, 3, 4, 5 times 100. And 1, 2, 3, 4, 5, 6, 7, 8, 9 times 50. Okay, so what do I got? I have 500 plus 450. This one is 950. And this one is 130 plus 240 plus 700 equals, and this one is 1070. This means I need some more clockwise torque around this point, and clockwise torque would be going down, which is good because I need it down. Okay, so how much torque do I need? 1070 minus 950 equals, I need 120 clockwise torque. Okay, so this is, I'm going to use this down force to get me that clockwise torque. So I just need to figure out 160, where do I put that 160 down force? How far over from here do I need it? Well, I need to put it over here far enough to give me 120 clockwise torque. So 120 should equal the 160 times x, which is how far over I need to put it. So if I do that, 120 divided by 160 equals, I get 0.75. So here's the first mark. So I'm going to come in here right around here at 0.75, and that's where I'm going to put both of these torques. So I'm going to put a 160 down right there, and I'm also going to put a 98 left, a 98 left. So there is the equilibrium force. That is the force that's going to bring everything into equilibrium. I can calculate that. I can do 98 squared plus 160 squared equals, and I do the square root, and I get 188 newtons. So my answer is going to be 188 newtons, okay, at 0.75 from the left end, right? I got to describe exactly where it's going to go. 188 newtons at 0.75 meters from the left end, and then I could say at, and I could figure out what is this angle right here? How many degrees below this beam is this force? So I'm just going to go from the beam extended. I want to go how many degrees below it. It is. That angle would be the same as this angle. So that angle, the tangent of that angle, is 160 over 98. So I can do 160 divided by 98 equals inverse tangent, and I get 59 degrees. So I'll say at 59 degrees below the beam. So there's three parts to your answer. You had to figure out the magnitude of the force, 188 newtons. That's 188. I had to say, where's the point of application on the beam? It'd be 0.75 meters from the left end. And what's the angle? It's 59 degrees. That force is 59 degrees below the extended beam. Okay, so that's a pretty nasty parallel forces problem. Hopefully that made sense and you can kind of understand that.